Okay, so I'm gonna make this, or try to make this as quick as possible so that you understand what you're supposed to do today. Um, so last class period, we discussed exactly what an electrolyte is. And as a refresher, an electrolyte is an ionic compound that when it dissolves in a solution, that ionic compound dissociates or separates into a positive and a negative ion. So, with since it dissociates into positive and negative ions, it is able to, or the solution is now able to conduct electricity. So today we're going to look at some electrolytes that are, well, they end up not being electrolytes. They are ionic compounds that do not dissolve in water. And if it doesn't dissolve in water, then you don't have the positive and negative ions that are needed in order to conduct electricity. All right, so let's start looking at some of those things. So the substitute should have given you the sheets for today. Sheet number 1. This is page, if I remember correctly, page 74. We're going to skip this one, and we're going to do this demonstration next week. All right, so glue this into your notebook on page 74, and page 2. We're gonna work on that one today. All right, this one, page 75 in your notebook. This is what we're going to do today. All right, so in order to do that work, you need the reference card from the front of your notebook. This is the reference card that has the polyatomic ions here on the left-hand side. And then in the middle, the charts really that we're going to use most are here in the middle. All right, and these tell us whether certain polyatomic ions, certain compounds, ionic compounds, are either soluble in water or insoluble. All right, so the example that we've been using is sodium chloride. So that's NaCl. All right, NaCl, that is that's the compound, the ionic compound that we've been using since day 1 of this unit. And we know that it's bonded ionically, and we know that because we're able to split it into 2 parts. One part being sodium, and the other part being chlorine. And what makes it, or what helps us to know that it's an ionic compound, is that when it does split into these 2 parts, the sodium will have a 1 plus charge, and the chlorine has a 1 minus charge. Now, we find sodium in group 1 on the periodic table. All of those elements in group 1, as we said on for your classes on Wednesday, those elements in group 1 will form ions, positive ions, those cation ions, with a charge of +1. And then chlorine is in group 17, as we said on Wednesday. Elements in group 17, when they form ions, they have a charge of -1. All right. The trend that we see in the periodic table: group 1 forms cations with a charge of +1. Group 2 forms cations with a charge of +2. Group 13 creates cations with a charge of +3. On the other side of the periodic table, those elements in group 17 form anions with a charge of -1. Group 16 form anions with a charge of -2. And group 15 elements form anions with a charge of -3. All right, so since sodium chloride splits into sodium and chlorine, we know that it's ionically bonded. All right, and really that's the first thing that you have to do for every single one of these on this chart for page 75, is you have to figure out, is this molecule ionically bonded? If not, then it's not going to be an electrolyte, because we have to have that positive and that negative ion in order to conduct electricity. And those electrolytes conduct electricity. All right, so once we see that it is an ionic compound, we've broken it into the cation and we've broken it into the anion. The next thing we need to know is, does that ionic compound dissolve in water? And that's where we'll use this chart from the front of your notebook. All right, the top chart here, these are ionic compounds that are soluble in water. That means they dissolve in water. These ones down here, these are ionic compounds that do not dissolve in water, and it's called insoluble. Right? And the reason that they don't dissolve in water is because water is not strong enough to pull apart that ionic bond. Right? Sodium chloride, it's held together because the positive ion is attracted to the negative ion. And when it dissolves in water, and we did this in the lab, when it dissolves in water, it pulls those ions apart. All right, and that's how it dissolves, and that's how it conducts electricity. In fact, when we look at this chart, the chart here on this side, this column here, that's where we're going to look for any of the ions that are in our compound. So in this compound, this example, we have sodium and we have chlorine. All right? So when we look at this chart, we're looking for either sodium ions or chlorine ions. We look, we see, oh, here's chlorine. Chlorine's right here, and that's in the top chart that says that it is soluble. We see that chlorine is soluble, so that makes us think that sodium chloride is going to be soluble in water, means it's going to dissolve, and it is an electrolyte. Now, before we can make that assumption, before we can make that final call, we have to look over here for common exceptions. For chlorine, chlorine's here, and we look over here, there are some exceptions. All right, there are some times when chlorine is insoluble. Most of the times, it's soluble. It dissolves in water. But sometimes, like when it's bonded to Ag, which is silver, all right, here, the chlorine is not bonded to silver. Another exception is when it's bonded to lead, Pb. Again, it's not bonded to lead. And then finally, the last exception is when it's bonded to Hg, which is mercury. We see chlorine, it's not bonded to mercury. So here, it doesn't meet any of those exceptions. So we say that sodium chloride is soluble because the chlorine ion is in the list of soluble ionic compounds. All right, so that's our first example. Let's do a few more examples before I turn you loose and you can do the rest of the chart. All right, so let's look at silver bromide. All right, silver bromide, we can split it up into two parts. The two parts that when we split it up, you have silver, which is Ag, And when we look at the periodic table, thing about the transitional metals is, for the purposes of this class, we're going to assume that it is an ion. And we're going to align that ion with the opposite ion. All right, so here we have silver and we have bromine. Now, we see that bromine is in, it's in group 17. So, as we just talked about, it's going to have a -1 charge. So, we're going to assume that the silver has a +1. Okay, so we have an ionic bond. We know that it's ionic. We have a cation. We have an anion. All right, now let's look at our chart, see if it's soluble in water. When we look down the chart, we see that right here is bromine. So bromine, it's up here in the soluble list. So bromine is soluble. All right, but we have to look at the exceptions. With bromine, exceptions are compounds that they're bonded with silver. Ag is the first one. We see here AgBr. All right, so Ag is an exception. So even though a lot of those bromide ionic compounds are soluble in water, since this one is bonded to silver, it's not. So since it does not dissolve in water, it's insoluble, this one is, it's not an electrolyte. It's a non-electrolyte. All right, so let's do 2 more. Okay, let's do no, not that one yet. Let's do calcium. CaPO4. All right, CaPO4. All right, now this one, and I really wanted to do this one because we have 3 elements. We have calcium, we have phosphorus, and we have oxygen. All right, so 3 elements. We need to split this into 2 parts still, even though there are 3 elements. When we split it into 2 parts, we have calcium and we have a phosphate. When we look over here at this list of polyatomic ions, we can find phosphate right down here. And on the list it tells us the charge. So phosphate has a charge of -3. So that's 3 negative. Calcium is found in group 2. So it's +2. All right. Now, here it's an ionic compound. We have a cation. We have an anion. Let's look at our list. So we look down the list. We're looking for calcium or for phosphate. When we go down the list, we see, oh, here, right here, we have phosphate. Phosphate is on the insoluble list. So we start off with the assumption that this is going to be insoluble and it is a non-electrolyte. We have to look at the exceptions though. With phosphates, the exceptions are compounds of NH4. We see the phosphate is not bonded to NH4, it's bonded to calcium. All right, so that one doesn't fit. The next one is an alkali cations. Remember from back in, I think it was about December end of November, beginning of December, we said that those alkali metals, all right, the alkali metals are group number 1. So calcium's in group 2. So it's not an alkali metal. Right? Since it's not an alkali metal, it doesn't meet that exception. So the exceptions are NH4, no, or alkali metals, no. So since it does not meet those exceptions, calcium phosphate is insoluble. All right, since it's on the insoluble list, phosphate's on the insoluble list, and it doesn't meet the exceptions. So this one, calcium phosphate, even though it's an ionic compound, is not soluble in water, and so it is a non-electron. Let's do one more. All right, this last one. Barium sulfide. All right, BAS. So when we split this into 2 parts, this one's pretty easy. There are 2 elements. So we split it into barium and sulfur. When we look at the periodic table, we see that barium is in group 2. So group 2 elements, those form ions with a 2+ charge. All right. Sulfur is in group 16. As we talked about before, group 16 elements, they form ions with a charge of 2-. So we have our ions. We have a cation. We have an anion. Now let's see if they're soluble in water. All right, we look down the list. We're looking for barium. We're looking for sulfur. Down here at the very bottom of the list for the insolubles is sulfur. So sulfur is, most ionic compounds with sulfur are insoluble. All right, now let's look at the exceptions. Exceptions are compounds of NH4. No, we don't have NH4. Alkali metal cations. No, barium's in group 2. Calcium. No, we don't have calcium. Strontium. Nope. And the last one is barium. So, this sulfur is bonded to barium, ionically bonded. All right. Barium's an exception. So, even though most or a lot of those ionic bonds, or the ionic compounds with sulfur, most of them are insoluble, barium's an exception. So since barium is one of those exceptions, that means that this ionic compound is actually soluble in water and it's able to dissolve, so it's an electrolyte. All right. So go ahead and fill in the rest of the table. And when I created the table, I put it in order for a purpose. Start off here with column number 1 for each molecule, for each compound. Start off with column number 1. Tell me whether it's ionic compound or not. If it's not an ionic compound, you can skip over cation, anion, and the solubility. All right? Because if it's not an ionic compound, you're not going to have an anion, you're not going to have a cation, and it's not going to dissolve in water. So it's a non-electrolyte. If it's not ionic, it's a non-electrolyte. You can go straight over here. Start off here. Tell me it's not soluble in water, so it's a non-electron. All right. If you have any questions, shoot me an email, and I'll try to answer it as soon as possible. This page 75, is a stamp for the notebook check for the Unit 7 test. All right. Go through, make sure you have all your work done, and we'll see you next week.